Hi, this is Lakshmi Kantiwari. Welcome back to your new lesson. In this lesson, I'm going to teach you about feature selection with the filtering method. So basically in this method, I'll be teaching you how you can remove a constant, quasi-constant and a duplicate feature removal. If you remember that in a previous lesson, I had mentioned that now I am going to start a new video series on a feature selection. So in a previous video, I had taught about the introduction of a feature selection in machine learning using a Python, and that was just a presentation. But in this lesson, I'm going to teach you about a filter method with an example. So initially, I'll give you the introduction about the feature selection of using a filtering methods, and then I'll tell you what is the filter methods, and then I'll tell you what are the methods which we are going to apply in this lesson. So those methods are a constant. Oops, I think this should be the constant. Okay. So here we have a constant, quasi-constant and duplicate feature removals, and you can also download the data files on which we will be working. From here, GitHub Lakshmi data files for the feature selections, and the link for this file is given into the video description from where you can get. And then I'll teach you, then I'll tell you how we can start working on the Santander dataset. And on the Santander dataset, so there are total 370 features, 370 dimensions. And then we will be first removing a constant features. Then we will be left with the 291 features. After that, I'll tell you how you can remove a quasi-constant features. Then we will left with 245 features. And then finally, I'll tell you how you can remove a duplicate features. And once we remove constant, quasi-constant and duplicate features, we will be left with 245 features. So this is the reduced feature space. Originally, we had 370. Now we are left with 245. And after that, I'll show you how you can compare the performance of the selected feature space. So with the selected features, we get the accuracy of 95.87%, but without selections, that's mean whole feature space, we get 95.85% accuracy. But you see here the training time, there is a huge difference in the training time. On original data set, we get 1.51 seconds of the training time, but on the reduced feature space data set, we get 1.26 seconds training time, which we can say that 16.56% of total training time gain. Okay, so this is all in this lesson we will be talking about. So let's do not waste the time. Let's go ahead and start working with this project, feature selection with the filtering methods, in which we will be removing constant, quasi-constant and duplicate features. Machine learning and deep learning algorithm learns from the data which consists of a different type of features. Let's say if you have a huge data set, it will be it could have a huge feature space as well. So if you have a huge feature space, then you need some type of algorithm which can select some highest performing features before applying machine learning algorithm. Otherwise, you might end up overfitting your machine learning model, which will deteriorate the performance of your model. The training time and the performance of a machine learning algorithm depends heavily on the features in the data set. If you have a large feature space, then definitely it is going to take a lot of the training time. And it is not always guaranteed that a huge feature space will result a better performance. Sometimes what happens, a particular set of features perform better than cumulative of all the features. So ideally, we should only retain those features in the dataset that actually helps our machine learning model learn something useful. And unnecessary and redundant features not only slow down the training time of our algorithm, but they also affect the overall performance of the algorithm. And the process of selecting the most suitable features for training the machine learning model is called a feature selection. And in this lesson, we are going to do a feature selection with a filtering method, in which we will be doing constant, quasi-constant and duplicate feature removal. There are several advantages of performing feature selections before training our machine learning model. And those advantages are listed below here, like models with less number of features have higher explainability and interpretability. It is easier to implement machine learning model with reduced feature space, and fewer features lead to enhanced generalization, which in turn reduces overfitting. And feature selection removes redundancy, and the training time of the model with fewer features are significantly lower, and models with fewer features are less prone to error. And the several methods have been developed to select the most optimal feature for a machine learning algorithm, and one of the such category is known as a filter method. And after this we will be learning about wrapper method, and then finally we will be learning about embedded methods of a feature selection. But for this lesson, let's go ahead with the filter method for feature selection. Now the question is comes, what is a filter method? Filter methods belongs to the category of a feature selection methods that select features independently of machine learning model. It doesn't involve any machine learning model while selecting a feature. This is the one of the biggest advantage of this method, since it doesn't involve any machine learning algorithm. That's why it is a pretty fast. Features selected using filter methods can be used as an input to any machine learning model. And another advantage of feature methods is they are very fast, and filter methods are generally the first steps in a feature selection pipeline. So this is kind of the best screening method to get a subset of the features. There are two kind of the feature selection methods in a filtering method. Those are univariate and the multivariate. In univariates, that's mean we select features without taking consideration of other features. That's mean kind of independent. For example, let's say if we have 10 features, then we can select some subset of the features without taking the information of other 9 features for particular features. So in univariate features, we can select the features based on a Fisher score, mutual information gain, variance, etc. But in a multivariate features, we take information of a feature to feature, and then we try to find out the best features out of those subset features, and the method from which we select known as a Pearson correlation. So in this particular lesson, we are going to learn a feature selection, univariate feature selection, and that will be particularly based on variance method. And in the next lesson, we will be learning about multivariate feature selection, and then after that we will learn about Fisher score and mutual information gain. Okay, so let's go ahead and learn in this lesson how we can select features, or how we can remove redundant features based on their variance. The univariate filter methods are a type of methods where individual features are ranked according to specific criteria. The top n features are then selected, and different type of ranking criteria are used for univariate filtering methods. For example, Fisher score, mutual information, which we will be learning next lesson, and in this lesson we are going to learn with the variance of the feature. One of the major disadvantages of univariate filter method is that they may select redundant features because the relationship between the individual features is not taken into account while making the decision. So univariate filter methods are ideal for removing constant and quasi-constant features from the data, which we will be doing in this lesson. Multivariate filter methods are capable of removing redundant features from the data, since they take the mutual relationship between the features into the account. So the multivariate filter methods can be used to remove duplicate and correlated features from the data. So the moreover, long story in the short, in this lesson we are going to learn about constant removal, quasi-constant removals, and duplicate feature removal. And you can download the data files from this link, and that is here. You see github.com/Lakshmi data files for the feature selection. You can go ahead at this link. Otherwise you can go ahead to my GitHub repository. At GitHub repository, go ahead into the repositories, and once you go in repository, select data files for the feature selection. and then we will be working on these two data files, Paribas data sets and Santander data sets. Okay, perfect. So for particularly in this lesson we will be working with the Santander data set. If you don't know about the Santander data set, you can search it here. Okay, Santander data set. Okay, so here we have Santander customer satisfaction data set. So this is kind of the data set created by a banking system. There they try to find out the customer satisfaction level, if customer is satisfied or not. Okay, so either you can download from my GitHub repository, otherwise you can download this data set from this Kaggle link. Now let's go ahead and start working with the algorithm. So the first we are going to remove constant features, then quasi constants, and then finally duplicate features. So before we start working with the feature removals part, we need to download we need to import the necessary packages into Jupyter Notebook, and those packages are numpy as np, pandas as pd, matplotlib.pyplot as plt, and seaborn as sns. Perfect. Now let's go ahead and start working ahead. So now we are going to import the train test split, random forest classifier, accuracy score, and variance threshold. Okay, so let's go ahead import those from sklearn. So here we need to import from sklearn, and then we have a model selection, import train test split. Okay, and once we have this, then go ahead and import random forest from sklearn ensemble. Okay, and here we have import random forest classifier, and then we have we need to import the accuracy score here. So from sklearn dot metrics, import accuracy score, and then from sklearn dot feature selection, here from feature selection import variance threshold. Okay, now let's go ahead and see the variance threshold into sklearn library. Okay, and let's go ahead and see what is this. So here in sklearn.feature selection we have variance threshold, and moreover we can learn about it more once you visit here official documentation at scikit-learn. So it says that this takes this kind of it has methods these methods fit transform, get parameters, get supports. Okay, and the get supports returns the selected features. Then it also says that inverse transform, which reverse the transformation, and the transform. So the fit and the transforms can be used together, otherwise fit transform you can use at a single time. So this is the way how we can use variance threshold. And if you go ahead and learn here about the feature selections, so these are some other type of the feature selections which we will be learning throughout this video series. Although in this lesson we are going to just learn about the variance threshold, but the further in coming lessons we will be also learning about other type of the feature selection methods which here we have. Okay, perfect. Now let's go ahead and import our Santander dataset. So we have a dataset. I have already downloaded this dataset from here. Lakshmi Mary data files for feature selection. So here we have santander.csv, put it into the same folder where this file is, and then we can load this, we can read this using pandas data frame. So here we have data is equal to pd dot read CSV, and then we have here Santander.csv, and for simplicity the number of rows initially which we are going to read, that is just 20,000. And now let's go ahead and visualize the first 5 rows of this data set, and those 5 rows are this one, and it says that it has total 371 columns. That's mean 370 features and 1 target. Okay, perfect. Since we are using here random forest or tree based classifiers, that means in random forest classifier we do not need to standardize our data set, since tree based models doesn't consider the scales of various features. Otherwise we might have needed a standard scaler to bring all these features space into single scale. Otherwise you see here this feature is having a quite large variables. That means the scale is quite high, but for these features the scale seems low. Okay, and similarly we need to do the same thing. Okay, although we don't need to do in this lesson, since we are going to just use a random forest classifier, okay, which is very immune to standardizations or normalization of a data set. Now let's go ahead and read these data sets into x and y vectors. So here in x we have data dot drop, and then here we have a target, and axis is equal to 1, and then here we have y. In y we have data that is a target, and let's go ahead and check the shape of this data set. Okay, so the shape here we have 20,000 rows and 370 columns, that is 370 features, and for y we have 20,000 rows. Perfect. Now let's go ahead and split this data set into training and the testing, and we will be applying feature selection on the training part of the data set to avoid any kind of overfitting. Otherwise we might have applied all the feature selections directly into the X, but that might we might end up into the overfitting. So to make it immune of the overfitting, we need to perform all the operation on the training data set, and once we apply on the training data set, and then similarly the similar operation with the training set, the parameters we can apply on the testing data set. I'll show you what I'm trying to say here. So let's go ahead, train and the test it is split. So here we have x train and x test, and then here we have y train, and then finally we have y test is equal to train test split. There we need to pass xy, and then the test size which I'm gonna use here, that is just 0.2. that is 0.2. That's mean the 20% for testing and 80% for training the data set. Okay, training the model. And after this we are going to set here the random state, and here random state is equal to the 0, and then here we are going to set here a stratify. The stratify is equal to y. Okay, perfect. So here we have a train test split of x and the y vectors. Test size is 0.2, random state is 0, stratify according to y. Let's go ahead and first work with the constant removal, then we will work for quasi constant removal. Okay. So for constant features removal, what we need to do, we need to first create a variance threshold object with threshold is equal to the 0, and then we need to apply fit and transform. So here we have the constant, let's say the constant filter. A constant filter is equal to a variance threshold, and here the threshold is equal to the 0. If you press shift and the double tap, you will see a detailed documentation about a variance threshold. Okay, perfect. Once we get a constant filter, then what we need to do, we need to do a constant filter dot fit, and that fit should be done on xtrain. Okay, so here we have constant underscore filter dot fit on xtrain. Let's go ahead. Here the constant filter is applied into the training set of the data. Now let's go ahead and work with the constant field dot get support. So here we have a get support, and get support returns that total constant field, the constant features. So here you see the get support, the features after constant removal. So it says that there are total 291 features are left after removing a constant features. That's mean there are total 70 and plus 9, 79 features were a constant features. Okay, so those features are removed here, and once those features are removed, then what we can do, we can also print the set of those features which are constant. Since this returns a non-constant features, if we invert this, then we will get a constant features. Okay, to invert this, what we can do, to invert this, we can get here the constant list. That means a constant feature list. We can create a list here, inverted list, not temp, for temp in constant filter dot get support. Okay, so in this way, what we can do here, this constant list will return that the true for all those columns which are a constant. And if you want to see those variables, then what you can do, you can just type here x and then columns, and then for those columns we can say here a constant list. So these are the here a feature space, and this is the total 79 features which are completely constant, and these are the name for those features which is present into a Santander data set. Okay, perfect. Now let's go ahead and transform the data set, xtrain data set, into a non-constant feature space. That's mean let's go ahead and remove all the constant feature space. Okay, so for that, what we need to do, we need to apply the transform methods on a constant field object. So xtrain underscore, let's say a filter, xtrain underscore filter is equal to a constant filter dot transform. Okay, and there we get here a train. Perfect. And similarly we can get x test underscore filter is equal to constant filter dot transform, and then here we have x underscore test. Perfect. Now you see here we had applied a constant filter, the variance thresholds on just a training data set, and we are scaling, we are transforming our test data set from the feature space feature set which we have got on by applying on the training data set. So this is how we avoid overfitting. Now let's go ahead and check a shape of x training and testing filter. So here we have x underscore train underscore filter dot shape, and then here we have x test underscore filter dot shape, and let's go ahead and get the shape of the x train for a comparison. So if you see here, for this one, for these two, we have 291 features left there. That means 79 features are removed. Those were a constant. But if you see here the X train, the original features were 370. That means the total features are 370. Now after removing a constant features, we are left with the 291 features. Perfect. Now let's go ahead, remove quasi constant features. Okay, so we have removed the constant features. Now we are going to remove quasi constant features present in these two data sets. Okay, xtrain filter and xtest filters. So here I can write here quasi constant feature removal. Okay, now the question is, you need to understand what is the quasi-constant. Quasi-constant features, as its name suggests, that these are the features that are almost constant, are quasi-constant. In other words, if I present it in another words, these features have the same values for a very large subset of the outputs, and such features are not very useful for making predictions, and these features unnecessarily creates overhead on your machine learning model. So there is no rule as to what you should there is no rule that what should be the threshold to select the quasi constant features, but in generals and widely we use 0.01% variance. That's mean the 99% that means 1% of similar non-similarity. Okay, so if we select the threshold is equal to the 0.01, that's mean we are going to remove all the feature sets if they are 99% similar. Okay, that means if I say here that a feature space which is almost contains a single value, right, which is almost a constant, but there is very a small chance, there is a very small amount that that feature varies somehow from the mean, that means the variance would be very low. We can say that that is kind of a quasi constant or somehow near to constant. So let's go ahead and see how many features are quasi constant in our present data set. So for that, what we can do, we can get a quasi constant filter object. So here we have quasi constant filter is equal to variance threshold, and there we have threshold is equal to 0.01, and then we have quasi constant filter dot fit, and then we have extrain filter. Okay, and after that we have quasi constant filter dot get support, and let's go ahead and see how many features are left which are not a quasi constant and not a constant. So now you see there are 245 features are left. That's mean the total, if you subtract 291 minus 245, that's mean 46 features are quasi constant in the extrain filter data set. Okay, so in this way we have got a quasi constant the feature set also. So if we do the transformation, then it will also remove those quasi constant features. Now let's go ahead and remove those quasi constant features, and to remove those quasi constant features, what we need to do, we need to apply a transform on a quasi constant filter object. So let's go ahead and get extrain underscore quasi filter is equal to quasi constant filter dot transform, and once we have dot transform, then extrain filter, and similarly we can get for a test data set. So x underscore test underscore the quasi filter is equal to quasi constant filter dot transform, and then x test filter. Okay, so in this way we have removed constant as well as quasi constant features from our training and the testing data set. Now let's go ahead and check the shape of the data set. So first we need to check the shape for extrain quasi filter. Okay, and let's go ahead and also check the shape for x test quasi filter. Now if you now if you see here, the shape for this data set is 245. That means there are total 46 features which were quasi constant. Okay, so till now we have removed a constant feature as well as a quasi constant features. So initially there were 370 features, and now we are left with 245 features. That's mean there were total 125 features which were either constant or a quasi constant. So in this way we have reduced our feature space or dimensionality of the features from 370 to 245. Now finally what we are going to do, now we are going to remove a duplicate features. So what is the duplicate features? If two columns, that's mean the two features are exactly same, that's mean those features are a duplicate. Okay, that means the duplicate features doesn't introduce any new information, but in fact it creates overhead to your machine learning model, and in that way it can just make a complex model, but overall performance would be reduced in case of if your dataset have a duplicate features. So let's go ahead and remove duplicate features. Okay, so now we are going to remove duplicate features. The duplicate features are features that have a similar values, exactly similar values, or 100% similar values. Duplicate features do not add any values to the algorithm training, rather they just add overhead and unnecessarily delay the training time and makes your model complex and reduce overall performance. Therefore, it is always recommended to remove the duplicate features from the dataset before training or applying your machine learning model. Now let's go ahead and first remove the duplicate features. So, but there is a problem, as we did into constant, in case of the constant and the quasi constant. The sklearn or any Python library doesn't have any direct library to handle with the duplicate features. So what we will do, we will first our transform the dataset, transpose the dataset. So in this case, after transposing the dataset, our rows will become a column and the column will become a rows, and then Python algorithms or Python methods have a method to handle a duplicate rows. So once we remove the duplicate rows, which was earlier before transposing where a column, that's mean where features. So once we remove duplicate features and then once again we will transpose it, that means rows will become again a column. So let me tell you how. So we are going to first get xtrain t, that's mean the transpose data of the training data set. Okay, so here we have xtrain quasi filter dot t. So in this case we are transposing, that's mean we are making rows to a column and the column and the rows. That's mean the feature vectors will become here now rows. So x underscore test underscore t is equal to x underscore test underscore quasi filter dot t. So in this case we have got transpose of training and the testing data set. Okay, now once we get this, let's go ahead and see the type of these data set. So if we have already did a transformation, okay, the xtrain t, let's go ahead and see. So after the transformation earlier, okay, this transformation, the pandas data frame has become the numpy array. Now to handle the duplicate, we need to change this numpy array into a pandas data frame. So let's go ahead and change this into a pandas data frame. Xtrain underscore t is equal to pd dot data frame, and there we have xtrain underscore t, and similarly for x underscore test t, for a test data set we have a pd dot data frame, and then here we have x test underscore t. Now after this we have converted our numpy array into pandas data frame. Now let's go ahead and check a save. So here we have xtrain underscore t dot save, and then here we have x underscore test underscore t dot save. So now you see the rows has become a column and the column has become a row. So there are 245 rows and 16,000 columns. Okay, so basically the transpose has occurred here. Now let's go ahead and get a duplicate. So let's go ahead and see how many features are a duplicate. And to get that, what we can do here, x underscore train underscore t dot duplicated and dot sum. So perfect, it says that there are 18 features which are duplicated. Okay, so now we need to remove these 18 features as well. So in this way we will be removing constant, quasi-constant and duplicate features. Now let's go ahead and get duplicated features. Okay, so in this way we will get duplicate features is equal to x underscore train underscore t dot duplicated. And if we print these duplicate features, you will see here true and the false kind of. Okay, so this says that these are the total the 245 rows, and in these 245 rows which are a duplicate, that will be the true, and which are not duplicate, that will be the false. Okay, so here we doesn't see any true, but somehow from these the 32 to 14 there are 18 rows which are duplicated. That's mean here you see the total 18 rows. Now we need to select those non-duplicated rows, right? So those non-duplicated rows, that's mean you see here from duplicated features it returns those rows which are duplicated. If we invert these duplicate features, that's mean these false will become a true and the true will become a false. In this case we will get all non-duplicated features. That's mean the duplicated features will be removed. Okay, so to do that, what we can do, that's mean the features to keep, that's mean those features which are not duplicated, we can get in the same way. Okay, by creating again a list, but inverted list. Then that's mean not index for index in duplicated features. Okay, so in this way we will get the features to keep. Okay, see here the false will become a true and the true becomes a false. So in this case we will get all the features which are not duplicated. Okay, perfect. Now after this, what we are going to do, we are going to get x train underscore unique. Okay, so here the training data set, unique training data set, which do not have constant, which do not have a quasi-constant, and which do not have a duplicated features. Okay, so in this case we get x train underscore t, and then here we get a features to keep, and then finally transpose. Now the rows will become a features again, that means rows will become a column. And similarly we need to do for a training testing data set as well. X train unique is equal to x underscore test underscore t, and then we need to do here features to keep dot t. So in this way we have a training and the testing feature set as well. Now after this, what we are going to do, now after this we are going to see the shape of the data set. Okay, so here we have x train unique dot shape, and then we have here x train dot shape. Sorry, here we have test, let's make it train. So in this way now you see initially our original data set had 370 features, but after removing a constant, quasi-constant and duplicated features, now we have 227 features. So there 370 minus 227, that's mean 143 features are removed. Okay, so out of 370 features, there are total 143 features are either constant, quasi-constant or duplicated. So in this way we have reduced our feature space from 370 dimension to 227. Now let's go ahead, build a model and compare the performance of the model on original dataset as well as these transformed dataset. okay, or on these selected features, just 227 selected features. Compare the performance of the selected features. Okay, perfect. So here we are going to first apply a random forest the classifier for a random forest classifier. So let's go ahead and first build a random forest classifier. Okay, so here we are going to type here run random forest. So here we have x train and x underscore test, and then here we have y train and then y underscore test. After this we have a CLF, that is the classifier, the random forest classifier, and there we have n estimators. We are going to put here 100 estimators, and then here we have a random state is equal to 0, and then here we have n jobs is equal to -1. Then here we have CLF dot fit, that's the classifier dot fit, the x train here, and then here we have y train. Now you do you should know here is that these x train y train is not original data set, but these are the data set which we will be passing in these methods. So here CLF dot fit x train and the y train. So here we have this one, and then here we have y pred is equal to CLF dot predict x underscore test. Now after this, what we are going to do, we are going to just print the accuracy on the testing the data set. Okay, so the print accuracy on test set, and then here we have a print accuracy score, and then y underscore test, and then y underscore pred. Okay, perfect. So in this way we have built our random forest classifier methods. Now let's go ahead and call these methods and get the accuracy. Okay, so here we have run random forest, and then here we have x train unique. In this way we get x underscore test unique, and then here we get y underscore train and then y underscore test. Let's go ahead and train this model. In this way we get 95.87% accuracy. Now let's go ahead and get total the training time as well. For total training time we need to run here a magic cell with the time, double percentage and the time, and run it. So it will tell you that how much time it took. So there are 1.26 seconds time to run this cell. That's mean it has also called this cell, that is 32 cell number. And we have got 95.87 accuracy. Now let's go ahead and run this on the original data set. So here we have run random forest. Okay, in random forest we are gonna run it into original data set, x train and x test, then y train, and here we also need to run here y test as well. Okay, so in this way we are going to run this, and then we are going to compare the performance. Now you see here the transform data set are the data set which have a selected features took just 1.26 seconds, but the original data set which had 370 the 370 features took 1.51 second. Okay, so there you see the gain into the time, as well as you can see a very minute gain into the performance as well. So in this, if you see the 95.85% accuracy, but on the transformed selected feature set, there are 95.87% accuracy. So somehow here we have got 0.2% accuracy, the 0.02% accuracy, a better accuracy. So the moreover with this, what we can make here the statement is that by selecting a specific features, we might not reduce the accuracy, but we might improve the accuracy, but we will surely improve the training times and we will reduce the complexity of a model. So in this way, we can also understand how much gain we have got from here. So 1.51 minus 1.26, then multiplied by 100 divided by 1.51. So in this way, you see here we have got around 16% of gain into the training time. So this is the huge gain. If we are talking about a huge data set or a big data set, where a huge data set are there, so in that case, the 16% gain into a training time without reducing the accuracy is phenomenal, and it's a fantastic. So this is the way, this is it in this lesson. So in this lesson, we have learned how we can remove constant, quasi-constant and duplicated features. And then finally, we have compared the performance as well. So thank you so much for watching this video. Please do not forget to subscribe this channel, and please do not forget to like this video as well. If you have any doubts, please comment below. Bye-bye. Have a nice day.